Don't forget to subscribe and ring that bell.
Okay, okay. We're done with multiple choice, and now we are going to start the short answer. We're going to do problems 25 through 32 of the January 2024 Algebra 2 Regents examination. Let's begin. For these 8 problems, and there are 8 of them, all right, each correct answer will get 2 credits. You can get partial credit here. So if there is a problem that requires you to do it algebraically, but you can do it in the calculator and get the right answer, write down that right answer, nothing else, and you'll still get 1 point out of the 2. Let's do some algebra. Number 25, factor this completely. We have x cubed plus 4x squared minus 9x minus 36. There always seems to be one of these. Whenever there's 4 terms, whenever there's whenever there's 4 terms, we factor by grouping. First things first is I want to make sure if I can take out a GCF that I do. There is no GCF to take out of these 4 terms. That's it. Okay? So we're going to go back to our nice parentheses. No, we don't want that. Cancel. Go back to our nice parentheses. And I'm going to factor something out of my blue parenthesis. It's going to be an x squared. It's going to leave me with x plus 4. And the whole point behind grouping is I also want an x plus 4 left over in the red parenthesis. That means I don't take out a 9. I want these to be positives. I take out a negative 9. Okay? And now they match. And what I do here is these two out of the parenthesis go in their own separate parenthesis. And these two that are the same, I just have to write it once. All right? And in case you didn't see this, shame on you if you didn't, we have adopts. It's a difference of perfect squares. It's going to be x plus 3 times x minus 3, and I still have my x plus 4. Pretty simple, but these are the 2-point problems, so they should be pretty simple. I love these. I don't care what anybody says. Determine if x plus 4 is a factor of 2x cubed plus 10x squared plus 4x minus 16. There are several different ways to do this. I could do synthetic division and see what the remainder is. Okay. I could do reverse tabular. All right. But what I'm going to do, because I don't need to know the quotient, in order to tell if something's a factor, if the remainder is 0, it's a factor. If the remainder is not 0, it's not a factor. Now, I could, as I stated before, divide these, or I can use the remainder theorem. What is the remainder theorem, for those of you that forgot? I take my factor and I solve it. In this case, x would be negative 4. This is the number that I'm going to put in for all of the x's into my equation here. So I've got 2 times whatever x is cubed. In that case, it's negative 4. Plus 10 times whatever x is squared. Again, our x is negative 4. Plus 4 times negative 4 minus 16. Whatever this turns out to be is going to be the remainder. This will not give us the quotient, but it will always give us the remainder. So in my calculator, all I've got to do is, there's our little spinning wheel of death at the bottom. And it's bye-bye. Clear this out. I'm going to put in 2 times negative 4, and that's going to be cubed, plus 10 times negative 4. Yo, dang you. There we go. Plus 10 times negative 4 squared. Right? Plus 4 times our x, which is negative 4, minus 16. All right, 0. It's perfect. That equals 0. That's the remainder. If I were to do synthetic division, my remainder would be 0. If I were to do reverse tabular, the remainder is 0. But we're not done because it asks us to explain. Since by the remainder theorem, that's what this is when I just plug in that number. By the remainder theorem, the remainder is 0, x plus 4 is a factor. Now, they will take points off. If you were to say right here, instead of saying the remainder is 0, if you were to say there's no remainder, that will get points taken off. Do not do that. There is a remainder, and it's 0. Now, what happens if this would have been 18 instead of 0? I could say x plus 4 is not a factor because the remainder is not 0, or because the remainder is 18. But in this case, the remainder is 0. Here's the answer. Here's the proof. And the proof is in the pudding, kids. And another easy one. The problem 27, an initial investment of $1,000 reaches a value v of t according to this model. V of t is 1,000 times 1.01 raised to the 4t, where t is time in years. Determine the average rate of change to the nearest dollar per year of this investment from year 2 to year 7. Average rate of change means slope. I'm not dividing it by slope. Average rate of change means slope. We do a lot of that in calculus, average rate of change and a lot of slope. So the only way I know how to take slope between 2 points, between when time is 2 and when time is 7, is I just do my change in y over change in x, which means it's going to be the change in v. Well, let's start. It's y2 minus y1 over x2 minus x1. The x's are time. Okay, the y's are my v value in this equation, the value. Okay, so I basically have from time 7 minus time 2. So this is time 2 minus time 1. Okay, and they give us that right here. Okay, but how do I find out the y's that go on the top? So basically what I have is I have 2 coordinates right now. I have a coordinate when time is 7 is an x, or in this case a t. And I have 1, 2 for an x or a t. But how do I find the y's here? Well, I just go to my original equation. I plug in the 7. That will give me the y value when x, or in this case t, is 7. Same thing here. How do I find the y when x is 2? Well, I go to my original equation. I plug in the x, or time, of 2. So I take my equation and plug in a 7. That's going to give me the y value, minus the equation when I plug in a 2. All right, so let's do this. I'm going to be kind of like tricky with this. And when I say tricky, not really tricky. Instead of plugging it in twice, I'm just going to do my equation, which is 1,000 times 1.01 raised to the 4x. Okay? And if I look at my table, I care about when x is 2. Y is this thing, 1082.85. And when x is 7, this one right here, 13, I don't know, I'll call that 0.3. So let's put this out here. So basically, what I have is when x is 2, we have 1082.9. Okay, and when x is 7, I have this 1321.3. So now I have the 2 coordinates to use, all right? So I have 1321.3 minus 1082.9 all over 7 minus 2. And that's just going right in a calculator, kids. Create a fraction. 1321.3 minus 1082.9 all over 7 minus 2. We get 47.68. So this is approximately 47.68, but they want it to the nearest dollar. So we'll call it 48 bucks. Really, if you know what you're doing, all this explanation is unnecessary. I'm just kind of reteaching this, but it's just changing y over changing x. All right, let's go. Let's do this. We have 28 says, when 1 over the cubed root of y squared times y to the fourth is written in the form where y is raised to some value m, what is the value of that value n? All right, justify your answer. They just want y to an exponent, so I've got to kind of combine this whole poopy poops. All right, well, let's first, I'm going to leave this y to the fourth alone. I'm going to change this bottom so it's an exponent. It's top down. The bottom came out, so it's 2/3. I'm multiplying them. That's what I'm doing. Right, now I'm going to take this and I'm going to flip it and bring it up here. And I got to negate the exponent. All right. I mean, some of you can multiply it together and then subtract. You can do that as well. It's fine. I just like to multiply and add. Yeah, I'm wondering, maybe I'll show you both ways. Now I got y to the negative 2/3 over 1, and anything over 1 is itself. Now I got to multiply it times y to the fourth. I add exponents now. Y to the 4 minus 2/3. All right, and keep this part in mind because I'll show you the other way, and it'll get you right to this point here. So it's y to the 4 minus, I got to make this so a denominator, actually, I lied. I want to make this so it has a denominator of 3. 4 is the same thing as 12 over 3 minus 2 over 3. That's y. 12 minus 2 is 10/3. So my n is 10/3. That's it. You're done. Now, I said there was another way. Instead of bringing this up, okay, instead of bringing this up, like I did right here, and I converted it, oh boy, let's just multiply these two as they are. I get y to the fourth on the top over y to the 2/3. Now, if I'm dividing, I subtract, right? Y to the 4 minus 2/3. And that still brings me right to this part right here. Still gives me the same answer. Okay, so you could, there's different ways to do that. I just showed you two. The answer is 10/3, and we're done with another easy one. Knowing how to use your calculator and where to go in there will get you a nice slew of points. 29. The heights of the members of a ski club are normally distributed. Oh, I love those words. The average, okay, let's start highlighting these. Okay, the average height is 64.7 inches with a standard deviation of 4.3 inches. Determine the percentage of club members to the nearest percent who are between 67 inches and 72 inches. This has normal CDF written all over it. Okay, normal CDF will give me a probability between the interval given here. You just got to multiply it times 100 to make it a percent. So where in the calculator, I'm going to have normal CDF, and I need to write this part down. You're supposed to put the lower limit first, the upper limit next. So my interval, my lower part of the interval to the upper part of the interval. My mean, which is 64.7. And then the standard deviation, which is 4.3. You need to write this. This will get on your calculator. Now, depending what calculator you use, okay, I have this one. If I go to seconds and above vars in blue, distribute, I want normal CDF. Now, it doesn't just put this right in for me. And forget that -1 to the e thing. That's crap. I'm just going to clear that out. My lower limit was 67 on my interval, all the way to 72. It's the upper. This little smushed m, I know it looks like a U. I call it a smushed m for mean. The mean represents the average, which is 64.7. And that little pigtail thing, that O with a little tail at the end, is my standard deviation, which is 4.3. When I hit enter twice, this is what I have written down, normal CDF on the paper. And I hit enter, that's 0.25158. So it's approximately 25.158. And they want that to the nearest percent. Okay, ooh, you know what? It's 0.25. I already multiplied it times 100. It's 0.25. Now, when I multiply it times 100, it's 25.158, or 25%. I mean, that is a gimme. How do I show my work? This is showing work right there. That's it. You are showing them how you got that answer. This one requires a little problem solving, but like just figuring it out. But it's not difficult at all. I say that a lot, but it really isn't. They give you an explicit formula. A to the n equals 6 plus 6n. That represents the number of seats in each row of a movie theater, where n represents the row number. Rewrite this as a recursive formula. A recursive formula means they have to give you the first term, and then you need to use that to find the next terms. Like, I'm going to have to use the previous term. That's what n minus 1 means in this equation somehow. So let's start by taking a look at the explicit formula they give us right here. Okay, if a to the n equals 6 plus 6n. So if I want to figure out what 1 is, it's 6 plus 6 times 1. That would be 12. That's my first term. Okay, if I want to find the second term, it's 6 plus 6 times 2. Okay, that's 12 plus 6, that's 18. I think you can see what's going to happen here. A to the 3 equals 6 plus 6 times 3, which is 18. It's 24. So I'm just adding 6 to every term to get to the next one. Okay, so when I write a recursive formula, I have to give the first element. The first element in my list is 12. I have to give that. And what do I do? To find the next one, I just take the previous one and I just add 6 to it every single time. So what I do here, okay, if I want to find some term, I take the term before it. That's what the n minus 1 means. And I just add 6 to it. That's it. It's that simple. We're done. There you go. Recursive form. Explicit is this way. They don't have to give you the first element. Okay? The recursive, they have to. Because without the first one, you can't figure out the second one. Without the second one, you can't figure out the third one. You need one to start. In this problem, it was too easy. All right, I think this is the first one that's going to be a little challenging. And by, it's a 2-point problem. It's kind of big for a 2-point problem. Not too big. But whatever it is, let's just get it done. All right, express 2xi cubed minus 3y squared. That means I need to multiply this times itself and represent it in simplest form. So I'm going to take 2xi cubed minus 3y squared. Okay, well, the first thing that I'm going to do with you is I'm going to tell you, anytime there's an I, if there's no other variables, I can put it in the calculator. But we have the x variable and we have the y variable, along with I, which is an imaginary number. There are two big things, that I squared equals -1 and I cubed is -I. Just for the sake of review, okay, for the sake of review, I to the power of 0 is 1, and I to the 1 is just I. And this repeats itself. But these are the important ones to know for this problem. Because I have an I cubed here. I can change that right now if I want. All right? So I cubed is like -I. So it's like 2x times -I, because that's what I cubed is, minus 3y squared. And if I multiply -I times 2x, it's -2xi minus 3y squared. Now I've got to multiply it times itself, okay? So I've got -2xi minus 3y. If I'm squaring it, I'm multiplying it times itself. Let's go. Here we go. -2 times -2 is a +4. X times x is x squared. And I times I is I squared. I know that's going to equal -1, but let's hold off for a second. I got this. -2 times -3 is a +6. There's no other x, so I'll just write the x. There's no other y, and there's no other I. So that's it. Now I do the same thing here. They're the same two terms, so I'm going to end up with the same thing. And last but not least, we got negative 3y times negative 3y, which is a positive 9y squared. The only thing I can combine are these two right now. So I have 12x, y, I. We have plus 9y squared. Okay, right here, this I is like a negative 1. I squared. Remember, I squared is negative 1. Negative 1 times 4x is negative 4x squared, and that's a positive. So that's it. So I guess just like converting this first and foiling it and converting the I squared, I mean, I said this is a lot of work for a 2-point problem. If you remembered your rules with I's, it really isn't. It's just foiling. I pray that you all get problems like this. Okay, number 32, in the last of the 2-point problems, in the last of this video. A survey was given to 1,250 randomly selected high school students at the end of their junior year. The survey offered 4 post-graduation options. You have 2-year college, you have a 4-year college, oh boy, you have, let's go orange, military, or you have work. Those are the 4 things we have. Of the 1,250 responses, 475 chose a 4-year college. State one possible conclusion that can be made about the population of the whole high school, or the whole high school junior class, okay? 1,250 randomly selected high school students at the end of their junior year. Okay, so that's not all of them. It's 1,250. There's more than that. Okay, so of those 1,250, 475 chose a 4-year college. So state one possible conclusion about the whole population of juniors, not just the 1,250. Well, first I'm going to put 475 over 1,250. And I'm going to see what that gives me. 475 divided by 1,250. Get rid of that decimal. That's 0.38. Okay, so that equals 0.38, which we will convert to 38%. So if 38% of these 1,250 are going to a 4-year school, chances are 38% of the entire population is going to a 4-year school, because we pulled the sample just to get an idea of what's going to happen to the whole population. And that's really it. So state one possible conclusion. There could be a ton of things you could do. All right, but let's just start and make it easy. 38%. This is one possibility, okay, of the entire, the entire population of the junior class, okay, will go to a 4-year college. I mean, it's just one possibility. Here's one. You can't tell me that's not accurate. That was cake. Just like the rest of these part 2 problems. I think we only have one more video. We're going to do problems 33 through 37. Those are the 4-point questions and the big one, the 6-point question. I'll see you for those later. Bye-bye.
Don't forget to subscribe and ring that bell.